So, hi everyone. So, we will continue with this session. We had said about the third method, which was Spearman rank correlation. And Spearman rank correlation is the third method. First one, which we discussed, was scatter diagram, and second one was Carl Pearson's correlation coefficient, and third one is another method, which is Spearman rank correlation coefficient. So, we will write Spearman rank correlation Spearman rank correlation, or simply we call it as rank correlation, okay, or simply we call it as rank correlation. So what is it? So suppose that we have a bivariate data as x1 y1 x2 y2 and say x and yn be the data. So we, in correlation, as you know, that we are interested in finding out the linear relationship between x and y. So we find out if there is any relation between x and y. And one of the demerits of we had another methods also, and one of the demerit of one of the demerits of the Carl Pearson's coefficient was that it consumed many time for calculation, and that is if the value of x was very high or something like that, value of x was very high, then the calculation part was a little more time consuming, as well as little more tidy job. So what we do is that so we introduce a much more simplified method which is known as Spearman, introduced by Spearman, and this method is known as Spearman rank correlation correlation. Okay, so what we do is that suppose that we have a n data setup, that is x1 y1 x2 y2 xn yn. So we have a set of x1 x2 etc xn variables. So what we do is we arrange this in so if we have like this xn variable, we rank them in such a way that the highest variable will be ranked as 1, next highest variable, then similarly the smallest variable will be ranked as n. Okay, so we will rank them accordingly as 1 2 3 then 4 etc up to n. We will rank in such a way that the highest one will be getting first rank. So which is the highest one? It will be getting the first rank, and the smallest one will be getting the nth rank. Okay, and similarly we will rank another variable, that is y1 y2 etc yn has the random variables, then we rank it as 1 2 3 etc up to n. Okay, then what we do is we find out the difference between the ranks of xi rank and yi ranks. Okay, we find out the difference between the rank of xi ranks and yi ranks. Then the correlation coefficient is given by rho equal to 1 minus 6 summation di square divided by n into n square minus 1. This is the formula for rank correlation coefficient. Okay, this is the formula for rank correlation coefficient, and this method is known as Spearman rank correlation coefficient, where some di is nothing but it is difference between the rank of first and nth. Okay, this is the basic idea behind Spearman rank correlation method. I hope that the method is very much clear to you. So we will look into, if we have some numerical examples, then we can look into that example so that it will be very clear to you. Okay, suppose that if I take a simple data, we will look into the data. Suppose that we have a bivariate data as, suppose that the bivariate data is suppose that we have it in the form that 1 6 1 6 then 6 2 6 2 comma 3 4 3 4 4 1 2 5 and another one, last one, 5 3. Okay, 5 3. So you know that these x values are nothing but, and we take the x values, as, you know, that 1, then it is 1 is there, then 6 is there, 3 is there, 4 is there, 2 is there, and 5 is there. So below this we rank them, though. So the sixth rank is the highest among all, so I rank it as 1. Okay, 6 is the largest one, and I rank correspondingly as 1, and 1 is the smallest one, and I rank 5 as 2, then I rank 3 as 5i, then 4 as 3, then 1 2 1 2, then 3 as 4, then 4, then 5 for 2 as 1 2 3 4 5, then here we can rank it as 6. Okay, 6. So correspondingly I have 6 1 4 3 5 2. This is the ranked data of xi. Okay, this is the ranked data of xi. Okay, this is the ranked data of xi. So now next we rank yi variables. Okay, next we rank yi variables. So corresponding to yi, 6 is the highest, and it will get 1, and 5 it will get as 2, and 4 3, and 3 will be getting as 4, and will be getting as 6, 2 will be getting as 5. So it will be 1 5 3 6 2 4. This is the thing. Okay, so we had ranked based on our original data. We have ranked in this way. I think that the idea is very clear of ranking. So we had given 6 was the largest, and corresponding to the largest I had given it as 1, and I had marked it in second place. Okay, and corresponding 6 was in the first place. So this is a single data xy, where first position was 6th largest data, and second position was first largest data 1. So I marked it as 6 1. Now what I do is I find out the difference between xi minus yi. Okay, I find out the difference between 6 minus 1 is 5, 1 minus 5 is 6 minus 1 is 5, 1 minus 1 is minus 4. Okay, 4 minus 3 is 1, 3 minus 6 is minus 3, 5 minus 2 is 3, 4 minus 2 is 2. Okay, I think that the idea is very much clear to you. Now I find out di square. So di I have 25, then 4 4 16, 1 9 9 4. So I have to add this 9 18 22 23 25. It will be 48 58 58 58 58 59 60 64. Okay, so the correlation coefficient is 1 minus di square by n into 1 minus summation di square by n into n square minus 1. So this was the formula. So 1 minus summation di square is 64 divided by n is 1 2 3 4 5 6. 6 into 6 square is 36. 36 minus 1 35. So it is 1 minus 64 by 35 into 36. 35 into 6. 6 30. it is 210, and out of this 64 has to be subtracted 6, and then 146 by 210 is the answer. Okay, you have to see, you can simplify it, it will be simplified. I don't have the calculator, and since I am recording in mobile also, then I cannot find out the answer, so it will be the answer. Okay, you can verify this thing. Okay, this is an example of what we say is Spearman rank correlation coefficient. We will find out the corresponding ranks of this data, then we find out in this way. Okay. I think that the concept of Spearman rank correlation is very much clear to you. Okay, then we will discuss about one more thing. So what will happen in case of tie? Suppose that two observation had been repeated here. Suppose that I had 6 and another also I had 6. So what should I do if there is a tie? Another case is tie. In the case of tie, what will happen in the case of tie? This is an important question. Next we will address that question. So in a byway, suppose that next we will explain about the case of tie. What happens in the case of tie is, suppose that the data is in this format: 1 6, then 1 7, and then 2 7, 3 6, like this is the data. Then here we see that this random variable x can take here 1 2 3, then here y take 6 and 7. So here 6 and 7 are repeated 2 times and 1 is repeated 2 times. So what will we do if these ranks are repeated more than one time? This is the question in the case of in the case of repeated ranks. Okay, this problem will be addressed by us in this section. Okay. So in this case, what the earlier definition of rank correlation coefficient was rho equal to 1 minus 6 summation dA square by n into n square minus 1. So this formula cannot be added since there is repeated rank. So we add another variable m, okay, which is which denotes number of times we can write in sentence number of times an item is repeated. An item is repeated. Okay, so we can write in detail. So in the case of common ranks, in the case of ties or common ranks, in the case of ties, or we'll write in another way, in the case of ties, common rank is assigned to the repeated variables, okay. Common rank is assigned to the repeated variables. We can take the common rank as the average means that mean. Okay, average mean of the ranks which these items would have assumed, if they are slightly different, if they are slightly different from each other, and next item will get the rank next to the rank already assumed. So in the case of tie, common ranks are assigned to the repeated variable. If we can take the common rank as the average mean of ranks which this item would have assumed if they are slightly different from each other, and next item will be given the rank next to the rank of already assumed. It does mean that, for example, we have 1 2 3, then let it be 4. Sorry, if you rank these things, suppose that 10 12 14, then 14 15 16 17. So I have to rank in such a way that the rank higher, the highest rank is 1, okay, then 2, then 3, it is 4 and 4, it should be 4 and 5, then 6 7. Okay, if I rank it in this way, but these two things are equal, so I have to take the ranks as such that I have to take the average of 4 and 5. Okay, so I take it as 4.5. The next rank will be 6. So this will remain as same, whereas this will be taken as 4.5. 1 2 3 4.5 4.5 6 7 will be the corresponding rank. As in another example, if we have 10 12 14 15 16 17, then what I will take 1 2 3 4 5 6 7 8 will be the corresponding ranks. So here what I have to do is, here since there are 4 5 6, so the corresponding average rank is, the mean rank is 5. So I take in this way that 1 2 3 5 5 5 7 8 will be my ranked data. Okay, that will be my ranked data. So it is how we rank a bivariate data in the case of a tie setup. I hope that the idea is very much clear to you. If you do some numericals, then you will be able to understand this common thing little more easy. Okay, so this is the basic idea behind this. Okay, so we can do 1 minute. Hence it is the basic idea behind ranking of the variables in case of repeated ranks. Next we move on to how the corresponding formula changes in the case of repeated ranks. So in the earlier case we had rho equal to 1 minus 6 summation di square divided by n into n square minus 1. So in this case what will happen is that we introduce another variable m, where m is nothing but the number of times each item is repeated. So what we do is that we have to so I will just explain. So our formula changes from sigma equal to 1 minus 6 summation di square plus a correction factor cf by n into n square minus 1. It becomes in this way. Okay, so where cf is nothing but it is m into m square minus 1 by 12. Okay, so cf for it, correction factor for x and correction factor for y contributes for CF equal to CF of x plus CF of y. In this way we find out the row the what we say Spearman rank correlation coefficient. If we do an example, then it will be very much clear to you. Okay, so we can write that in case of repeated ranks in case of repeated ranks we add the factor m into m square minus 1 by 12 to summation d square where m is number of times each item is repeated, where m is each number of each time is repeated. Thus row becomes so this is the expression for row. Okay, you can write, in the case of repeated ranks we add the factor m into m square minus 1 by 12 to summation d square, where m is number of times each item repeated and row becomes this way. Okay, I hope the concept is very much clear to you. Okay, so we can do an example. So suppose that we have the data for x, we have 68, 64, 60, 75, 50, then 64, then 80, then 75, then 40, then 50, then 64. This is for the x variable. Then for y variable we have 62, 58, then 68, then 45, then 81, then 60, 68, then 48, then 50, then 70. So this is our data. Okay, now we have to find a rank correlation coefficient, rho. Okay, this is the question. So from the question itself, suppose that we take first part x. Okay, so here 64 is repeated 1 time, 2 time, then 3 time. Okay, similarly then 75 is repeated 1 time, 2 time. Okay, if we take in the case of y here, then here we have 68 is repeated 2 times, nothing other than that is repeated. Okay, 68 it repeated 2 times. So I write x data, then y data. So I write simply x 68, 64, 75, 50, then 64, 80, 75, 40, 50, 64. This is the data. Similarly for here 62, 58, then 68, then 45, 81, 60, 68, 48, 50, 70. This is the data. Okay, next I take it as rank of x, or simply I write rank of x, simply I write it as x of I or something like this. Next I find rank of y of y. So here the greatest value here it is there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Then the highest value will be 1 and lowest value will be 10 in the rank section. Okay, So among the x variables, 64 is repeated 3 times, so the average will be 64, and 75 is repeated 2 times. Sorry, the average will be the corresponding position of that time. So let us rank this random variables, and here we see that 80 corresponding to 80, it will be the highest, and corresponding to 80, it will be the highest. Okay, so we will rank it as 1, and next it is 75. Okay, next it is 75, rest all are small. Okay, 75. So 75 the position becomes 2 and 3. Okay, 2 and 3, so the average will be 2.5. okay, so we write it as 2.5 since it is in the position. So 2 and 3 over 1, 2, 3 over, the next is fourth one will be corresponding to 68. It will be the fourth one. Then next we have 64. So 64, 1, 2, 3 times it is repeated. So fifth position, sixth position, seventh position, it is repeated. So what I do is that I take the average of these 3 positions, that is sixth position, 5, 6, 7, the average is 6, so I take it as 6, and last one 6. Okay, then we don't have anything repeated else. Then we 50 is repeated 2 times. 50 is repeated 2 times. So change this to 55, then it will be okay. Change it to 55, then it will be okay. It is a worked out example actually, so let us do change that, some changes in the question. Then we have correspondingly to then we have it as 9th position in here, then 10th position and 8th position corresponding. Okay, then we can write a rank of phi in this session. Rank of phi is corresponding the highest variable is here 81 is the first variable which is highest. Then if we rank these random variables, it will be 70 is second variable, and then next variable is 68 is repeated but 2 times, so third and fourth position. 3.5 is the average. 3.5 is the average. Third and fourth is over. Then fifth position 62 will be in the fifth position, and correspondingly we can write 7th position, 10th position, and then corresponding to 60 it will be in 6th position, then 50 it will be in 9th and 8th position. Okay, then I find out di, that is xi minus yi. Okay, so 4 minus 5 it will be minus 1, minus 1, minus 1, minus 1. So 6 minus 5, 5, here minus 5, then here 1, 10 minus 1, 1, 8 minus 8, 0, 6 minus 2, 4. Now we find out the square of this value. So square is 1 plus 1 plus 1 plus 1, 25, 25, 1, 1, 0, 16. This is the answer. Okay. Now we have to find out what is summation di square. So if you sum this, it will be 72. And if you sum this, it will be 415, 5, 5, 5, 0. 0. Okay. Now we have to find what is m. So first I write it for correction factor of x. So it was m into m square minus 1 by 12. Okay. So here you see that 64 is repeated 3 times. Okay. So m is number of times m denote number of times an item is repeated. So 64 is repeated 3 times. So 3 into 3 square minus 1 by 12 plus, in this 75 is repeated 2 times. So 2 into 2 square minus 1 by 12. So correspondingly we have 2 into 4 minus 1, 3 by 12 plus 2 into 4 minus 1, 3 by 12. So it is 2 into 3 by 12. Okay. So it is 4, 4 3 is 12, 5 by 2. Though it is 3 2 9 9 9 8 അല്ലേ 8 ആണ് വരിക, ഇത് വരില്ല. 8 2s are 16 by 12 അല്ലേ, 2 2 6 4 by 3 plus 2 6 by 12 1 by 2 1 by 2 no 6 4 into 2 8 plus 1 3 into it will be 5 by 2. Okay, it will be 5 by 2. I had made some mistake here, just to recheck it. Okay, some problem, or let me do once again because it is first problem. So m into 3 square minus 1 by 12 plus 2 into 2 square minus 1 by 12. Okay, this 3 into 9 minus 1 8 by 12 plus 3 into 9 minus 1 by 12 plus 2 into 4 minus 1 by 12, 24 by 12 plus 4 minus 1 3 3 2 just 6 6 by 12. So it is 12 2 2 plus 1 by 2, it is 4 plus 1 by 2 5 by 2. 5 by 2 is the answer. So CF for X is 5 by 2. Okay, CF for Y, next I calculate CF for Y. CF for Y, it is m into m square minus 1 by 2. So it is here, in case of Y, 2 variables is repeated. So you take 2 into 2 square minus 1 by 2. So it is 2 into 4 minus 1 by 2, 6 by 2, 6 by 2, 6 by 12, 12, it is 12, 12, sorry, 12, 6 by 12 or 1 by 2, 1 by 2. So total correction factor becomes 5 by 2, 5 by 2 plus 1 by 2. That is correction factor of X plus correction factor of Y. So it is 6 by 2, or it is 2 3 3. Okay, correction factor is 3. Okay, so my row becomes 1 plus 6 summation di square plus correction factor divided by n into n square minus 1. 1 minus is there. Okay, 1 minus 6 summation di square is nothing but 72 plus 3 whole divided by 10 is the total number of observation, and 10 square is 100 minus 1 99. So if you calculate, you will get around 0.545. Okay, so in this way we can do for rank correlation coefficient. I hope that the idea is very much clear. If it is not clear, then repeat the class for once again, then you will understand and you will get the answer quite nicely. If you have any doubt also, I can take one more class on this. Before that, I will do one more thing. I will add some question booklet, so you can work out that question booklet in your as assignment, and you can submit after 2 days. I will you can do it for Tuesday or Wednesday, and then you can, I think that in Wednesday you can do, then you do that thing for Wednesday. I will add it in the assignment section in Google Classroom. Then in case of any difficulty or anything, you can ask me. So I think that today's class, it's we can stop here, and we can move into another section next day. Thank you.